right, time for Wise Guys Wednesday. Get excited.
Which means time to learn yet another lesson from U of I physics professor Paul Kwiat. Good morning, sir.
Good morning. How are you guys?
Doing great.
You're doing good, yeah.
As always.
Oh, well, see, it's got a little Cheerios on it.
Oh,
yeah, I see
didn't
that.
even pick up on that. And we are talking about cereal today.
We are talking about cereal and a really interesting phenomenon that was brought to my attention, which is that I have here an ordinary Cheerio, and I'm just going to put it in water over here. We'll see if our camera can zoom in on this.
Okay.
Yep.
So, and I also have here a nice magnet, kind of a pretty strong magnet. And you see that under the influence of the magnet, I can pull the Cheerio. Okay, now it's stuck by surface tension in the middle.
Just pull it.
So
Yeah,
I'll just move it into the middle. I can pull it along.
So Cheerios can't be magnetic. Have we been lied to our entire lives?
Well, that's the question. Can Cheerios be magnetic? In fact, I took some Cheerios here and I just ground them up in here. And if I put my magnet inside of it, in fact, it pulled off a whole bunch of Cheerio dust on it.
Wait.
So the thing is that Cheerios, in fact, are magnetic because if we pull up our first graphic for Cheerios,
I do believe we have that handy.
and lots of cereals, right down on that circle thing there, it says iron. It is fortified with iron with 100% of your daily recommended allowance of iron.
Okay.
So in fact, the Cheerios are magnetic, and when I put this in, it's picking up the magnetic particles of the Cheerios. So it turns out lots of cereals, lots of foods have some iron in them, and so here we're going to do a little experiment. Here we have Cheerios on one hand.
It's like a floating...
And Fruit Loops on the other hand.
Yeah.
Yes. And I have a little bit of this is a bigger magnet, so we want to stay away from this one, so like from your credit card. And I'm just going to put this in the middle, and once I get it to stop moving, and we're just going to see what happens when it's in the middle, and you see that, whoop, it's definitely attracted more to the Cheerios than it is to the Fruit Loops. Let's just try one more experiment just to make sure it didn't have to do with how the thing was oriented.
Sure.
Yep, so again, put it in the middle and whoop, it goes straight to the Cheerio
Those poor
side.
Fruit Loops. Rejection is tough.
Well, so if you look on the side of Fruit Loops, it turns out that they have 25% of your daily recommended allowance of iron, not 100%, and so they have 1/4 the amount of iron, so you get more attraction to the Cheerios instead of the iron. Not everything is magnetic, so something that doesn't have any iron are marshmallows, it turns out. So I just put my marshmallow in here. I have to stop this whole thing from moving. And in fact, it's not really affected at all by the magnet. So not everything is magnetic.
So foods that have iron in them are generally magnetic, or is it just because
the iron itself is magnetic? So the iron is attracted to magnetic fields, basically. The little magnets in the iron, the little atomic magnetic moments line up with the magnetic field.
Well, now I'm going to be carrying around a magnet and just putting it to my lunch. And
or putting it to other things. So, for example, it turns out that money is also the ink. They use magnetic ink in the money, and so if I just pull this close, you can. Let's see, how am I supposed to hold it?
Do you need me to take the money?
I can just hold this, and you can see that it's being attracted a little bit. It's a little hard to see when it's just freestanding like this, so I made myself a little $1 flotilla. $1 bill, folded up $1 bill, and you'll see in this case, whoop,
Oh my gosh.
Yeah, so the ink is very magnetic. They use that as, there's some iron in it. They use that as anti-counterfeiting because most counterfeiters are not going to have ink that has
That's magnetic.
That's magnetic.
Okay, some shady guy in a shack out there is taking notes about this.
So
you learned something today.
Indeed. So we will play more around with magnetism next week.
This is so cool. What was the tape one for?
The tape one was just so that it didn't get soggy.
Oh, okay.
And so I just wanted to kind of explore.
I just wanted to make sure we didn't miss anything.
Explore what that was going to be. Yeah, so we'll play around with more things on tape next week.
Wow.
Yeah.
Getting loopy.
Indeed.
Right? All right, Paul. Thanks, as always.
Thanks, Paul.
If you have questions for our Wise Guys, go to our Facebook page. You're looking for ideas all the time.
All the time.
You guys wonder how something works.
Yeah, everyone, you guys can do this at home if you have like a really strong kitchen magnet. You might be able to do it. These are neodymium rare earth magnets that are extremely strong. That might be in hard drives, but a lot of times people on their kitchen magnets, they might have one that's strong enough that they'd be able to just pull Cheerio through water.
And this is good for kids to see too, with cereal, something they're used to.
Absolutely. So I told this to lots of scientists, and we were all very surprised by this because none of us thought about the fact that it's fortified with iron, and therefore it's going to be magnetic.
Well, me neither.
Interesting.
All right, cool.
All right.
Chip, chip, Cheerio.
Cheerio.
Cheerio. Well, still to come, a club in Coles County is helping kids get through some tough times.
It's called the Misfit Triathlon Club. We're going to sit down with a couple who started it and learn more about where they got the idea.